Picture a live sports broadcast playing on your screen. You see the sweat on the players' faces. You watch the exact parabolic arc of the ball. You feel the heavy physics as players collide on the field. Beat? Now realize that none of it actually happened. A neural network just hallucinated that entire sequence perfectly. It rendered every single pixel from scratch. So what does that mean for our shared physical reality?
It means reality is getting a massive back-end upgrade, or at least, well, a very convincing stunt double, one that never actually sleeps.
Welcome to today's deep dive. Our mission for you today is very clear. We are exploring a critical shift in technology right now. We are moving away from AI that just talks to you. We are arriving at AI that actively acts and builds.
Right, the transition from simple chatbot to active digital participant. It is happening incredibly fast across every single industry.
If we want to see what this shift looks like, we have a clear roadmap. We will start with Meta's new autonomous agents. They are quietly pulling your Instagram photos right now. Then we will track how these agents are invading our professional workspaces. After that, we examine the terrifying friction when these algorithms misfire. Finally, we look at how neural nets are simulating entirely fake physical worlds. They're doing this just to train real-world robots.
Yeah, it is a massive leap forward in capability.
Yeah.
The sheer scale of this is truly hard to comprehend.
Let us ground this shift by looking at Meta's new rollout first. Muse Image is live everywhere right now. They're also teasing something powerful called Muse Video. These tools were built by the Meta Superintelligence Labs.
And it is vital to understand this is not just a picture generator. It operates as a full-blown autonomous agent.
An autonomous agent, meaning software that plans and executes tasks without constant human prompting. It actively searches the web for factual accuracy. It meticulously plans out complex visual layouts behind the scenes.
Exactly. It does not just wait for your command. It actually self-refines its own work. It catches and fixes its own mistakes before you even see the final result.
That is a wildly crucial feature. I still wrestle with prompt drift myself.
Oh, prompt drift, yeah. That is when AI gradually loses track of your original instructions. You ask for 3 changes and it forgets the first one. It is endlessly frustrating for users.
It really is. But Muse Image corrects itself iteratively. It can even write and execute its own Python code. It generates mathematically accurate data plots from raw numbers. It builds fully working QR codes and animated GIFs.
It even generates interactive visual games on the fly, all stemming from one simple text prompt.
The model is live across their entire ecosystem. You can find it in the Meta AI app, Instagram, and WhatsApp. It is paired directly with their Muse Spark LLM,
which is their underlying large language model. Because the system can fundamentally reason, it handles incredibly complex tasks. You ask it to build something detailed for you, it maps the visual grid perfectly.
It handles the typography with professional precision.
Right. It outputs clean, legible text every single time.
It also scales its power using something called test time compute,
which just means giving the AI extra processing time before it answers.
So if I am understanding this test time compute idea, it feels a bit like cooking. Think about letting a chef simmer a complex sauce for hours instead of just throwing it in the microwave for 2 minutes.
Right, and the result is a much richer, deeper flavor. Or, in this AI context, a mathematically superior image. The more time it gets to think, the higher the ultimate quality.
All this generated media gets an invisible digital watermark. But here is where it gets highly personal for you. On Instagram, you can now use a simple app mention. It actively pulls your friends' public photos into these AI-generated images.
Just by tagging their username, yeah. The AI grabs their face and seamlessly integrates them into your synthetic scene. It is kind of wild. 1 minute you post a picture of your coffee. The next, an AI agent is using your face in a sci-fi movie.
It is totally frictionless for them, but a bit of a jump scare for you. Meta does include an opt-out setting for privacy in the menus. But public accounts are included in this feature by default. There is no notification sent to you when it happens.
That is the ultimate trade-off with these massive social platforms. Frictionless features almost always require frictionless data collection in the background.
So why would a massive company choose a silent default opt-in for our personal photos rather than asking for our explicit permission first?
Well, it is entirely about reducing the friction for mass adoption. If people have to manually dig through settings to opt in, usage drops to almost nothing. To train these robust agents, they need massive continuous data sets. By making it default, they guarantee a massive pipeline of real-world visual data. It benefits their underlying models immensely to just quietly collect it.
So public default means we train it unless we actively hide.
Yeah, that is exactly right.
We are letting these autonomous agents loose on our personal photos. But that is honestly nothing compared to what is happening at work. These agents are quietly taking over our professional backgrounds.
The deployment rate of background AI tools is staggering to watch right now. We are moving way beyond basic email drafting.
Look at a tool like Claude Cowork. It is now available on both web and mobile platforms. It keeps working on your projects even when your laptop is completely closed.
Anthropic just doubled the cowork usage limits through early August. It is essentially a relentless digital assistant that never clocks out.
Then you have something like Gemini Spark from Google. It intelligently tracks complex topics across the web for you. It even reacts to live sports events in real time.
You can have it automatically email you deep game analyses. Right after your favorite team plays, the report is just waiting in your inbox. It is always watching the feed so you do not have to.
The legal sector is seeing massive disruptive investment here too. Look closely at a company called Norm Law. They just raised $120 million in their Series C funding round.
That massive raise brings their total valuation to $1.2 billion. We are looking at a billion-dollar AI law startup.
AI agents are handling actual, billable legal work there. They operate under the supervision of human attorneys, but I want to unpack the implications of this for a moment.
It is entirely changing the traditional billable hour model. Imagine an AI ingesting 10,000 pages of discovery documents in seconds. The agents do all the heavy lifting and cross-referencing.
The human lawyers just verify the final output.
Exactly.
It is not just the legal field being disrupted. Catalyst is an AI sales agent designed specifically for teams on Salesforce. It runs its background processes 24 hours a day.
It reads every single client call transcript and email thread. It actively surfaces the right buying signals from the noise. It then prompts the human sales workers on exactly how to act.
There's also a platform called Badge. It is an AI agent that autonomously collects peer reviews.
It builds cryptographic proof of work for modern job seekers. You get a verified portable trust score that you own. All of it is managed and authenticated by an autonomous agent.
I have to push back hard on this transition, though. There's a deep, legitimate anxiety about this always on AI.
Oh, absolutely.
If Claude and Catalyst are reading every single email while we sleep, if AI agents are drafting actual legal contracts in the background, what happens to our fundamental human agency?
That is arguably the defining philosophical question of this era. Your role shifts entirely. You become an editor of outcomes rather than a creator of inputs. Your agency shifts from doing the actual task to judging the final result.
But if I'm just clicking approve on legal briefs all day, I am going to get lazy. Automation complacency is a real psychological phenomenon. If these systems are constantly acting autonomously, how do we prevent these tools from creating massive, unseen liabilities?
Well, you have to implement extremely strict verification layers.
Yeah.
Yes, the AI drafts the complex contract or the sensitive sales email, but a human finger must physically click send or approve every single time. You build hard guardrails where the AI cannot finalize critical actions independently. The legal and financial risks of unchecked autonomy are simply too high right now.
Human in the loop is the only way to scale safely.
Exactly. The human must remain the final, accountable gatekeeper.
The human absolutely must be in the loop right now. Because when these systems are left entirely alone, they can spectacularly fail. Insert mid-roll sponsor read marker here. Let us examine the dangerous friction of true autonomy. When rigid algorithms make decisions without human oversight, things inevitably break.
And because of the speed of software, they usually break at massive scale.
Look at the recent moderation misfire over on Discord. Over 8,000 active users were wrongly banned from the platform.
They were just completely locked out of their accounts without warning.
All because harmless, grid-like images triggered false, harmful content matches. The automated AI moderation system misfired incredibly badly.
It saw a geometric pattern
Yeah.
and completely hallucinated a severe violation. This is what pattern matching looks like when it runs amok.
But why does a simple grid confuse an advanced AI?
Computer vision often relies heavily on basic edge detection in its early layers. So when it sees a dense, repetitive grid, the neural network gets overwhelmed.
It misinterprets a harmless tile background as a known mathematical fingerprint for illicit content.
Right. It lacks all basic common sense.
It is like stacking Lego blocks of data. If the foundational block is structurally flawed, the whole automated tower just collapses.
That is a great way to picture it. The AI does not understand human context at all. It just sees a mathematical grid and applies a strict binary rule.
And suddenly, 8,000 innocent people pay the price for that rigidity.
Yeah.
Contrast the algorithmic software failure with the hardware side. There is a massive infrastructural arms race happening right now. The software clearly still has flaws, but the hardware push is absolutely relentless.
The global race for raw compute power is accelerating daily.
OpenAI is reportedly days away from another massive release. Industry reports say GPT 5.6 Ultra is coming to their Codex platform.
The full GPT 5.6 family is expected to land very soon. That represents a massive evolutionary leap for these coding agents.
But the physical hardware side of this is even more fascinating. DeepSeek is reportedly developing its own custom AI inference chip.
Meaning hardware designed specifically to run these AI models incredibly quickly.
Why would a pure software company decide to build physical chips? It is massively expensive.
It is, but this could reduce their heavy reliance on NVIDIA and Huawei hardware.
It definitely pushes China's domestic AI chip race much further. They clearly want total vertical integration from the silicon up to the software. But why is a company like DeepSeek pivoting to expensive hardware when the software is still making basic visual mistakes?
Because compute power is the ultimate bottleneck for fixing those mistakes. Software only gets smarter through massive continuous iteration. You cannot iterate if you cannot afford the raw processing time. NVIDIA practically controls the global market pricing right now.
If DeepSeek owns the silicon, they control their own destiny.
Exactly. They can train larger models much cheaper, eventually fixing those exact visual mistakes.
DeepSeek is building roads because NVIDIA owns all the toll booths.
That is exactly it. You simply cannot win the race if you cannot afford to drive on the track.
So physical hardware limits are being bypassed just to process our current world. But other researchers are using that exact same hardware to simulate entirely new worlds from scratch.
This is the part of the shift where things get truly mind-bending.
Let us talk about the massive Kyutai breakthrough. Kyutai and General Intuition recently teamed up with Epic Games.
They publicly released something incredible called MRA. It operates as an open-source world model.
A world model, meaning an AI that actively simulates the physical rules of an environment.
Right. And this MRA model generated a live 2 versus 2 game of Rocket League.
It did this entirely inside a neural network. Let that sink in. There is no traditional code rendering the game engine. The AI is literally dreaming the game into existence in real time.
It gets even crazier than that. There is absolutely zero human gameplay in the training mix. They used no human player data anywhere in the pipeline.
MIRA learned how to generate the complex game environment just by watching. It watched 10,000 hours of video footage of AI bots playing against each other.
Just absorbing the raw pixels on the screen. It was learning the laws of physics purely from silent observation.
It successfully renders incredibly complex environmental details. It correctly handles high-speed physics-based crashes. It even renders the dynamic boost meters accurately as they deplete.
It manages to keep all 4 players' distinct screens perfectly synced together.
Here is the wildest part for me. When the game triggers a goal replay, the model hallucinates completely convincing footage. It shows a dynamic goal that never actually happened in reality.
The neural net invents an entirely new camera angle for a synthetic event, and the physics of the replay look absolutely flawless.
The entire hallucinated game runs at 20 frames per second, and it does this on a single NVIDIA GPU. One graphics card is rendering an entire cohesive universe.
And they generously open-sourced everything for the community. The core code, the training data, and a playable interactive demo.
Do sex silence. Whoa, imagine scaling to 1 billion queries.
Exactly. If one single GPU can simulate the physics of Rocket League, imagine what a massive server farm could do. It could simulate the traffic patterns of an entire living city.
We are definitely seeing a clear pattern emerge in this space. This release comes right on the heels of other environment models, like that multiplayer GoldenEye simulation we saw recently.
AI is rapidly moving from generating flat 2D images. It is now generating fully interactive 3D physics environments.
But as the companies involved are very quick to point out, the end goal here is not to replace the video game industry.
No, games are just the accessible testing ground for the technology.
So why build a fake video game at all? What is the actual end goal of simulating a physics engine inside a neural net?
Well, the real mission is to create massive amounts of synthetic data. That is, artificial information generated by AI to train other AI systems. You cannot train a physical robot by having it crash 1 million cars in the real world. It is way too expensive and incredibly dangerous.
But if a neural net perfectly simulates gravity, friction, and momentum,
you can train the robot's digital brain millions of times inside that simulation. When you finally put that brain into a metal body, it already understands our physics perfectly.
We are building fake worlds so robots can survive the real one.
Exactly. The fake world is just a hyper-efficient gym for physical robots.
Let us pull all these massive threads together for you. We started this journey with AI acting as a simple chatbot. It was just a text box you occasionally asked for help with an email.
Now it has evolved into something entirely different and far more capable.
Meta is actively building autonomous agents that write flawless code and curate our personal photos. Background agents are running our complex legal desks and sales flows while we sleep.
Hardware companies are desperately racing to build custom chips just to process it all efficiently.
And neural nets are simulating entire physics-based worlds from scratch, all to safely train the physical autonomous robots of tomorrow. The overarching theme for you to take away is this: AI is no longer just a tool you occasionally use. It is rapidly becoming an environment you inhabit.
You do not just actively prompt it anymore. You essentially live inside its continuous background processes.
Which leaves us with a final, provocative thought to chew on. Kyutai built a flawless physics simulation just by having a neural net watch bots play a game for 10,000 hours.
Just pure, silent observation naturally turning into perfect physical replication.
Think deeply about that for a second. If a model can learn the fundamental rules of physics just by watching video, what happens when these highly advanced systems spend the next decade continuously watching us?
Watching our daily traffic feeds, our office security cameras, our personal digital lives.
How long until they can simulate human behavior and psychology perfectly?
It is an incredibly fascinating and honestly slightly terrifying horizon to look toward.
Thank you for taking this deep dive with us today. Remember to always keep questioning the data around you.